that will be talking about driving sustainable production from existing wells. So with that, before I hand it over to them, just a quick note. Please put in your comments, your questions during the course of the presentation. You can do this in the comment section, be it on LinkedIn or YouTube, and the speakers would address them after the presentation. All right. So with that, I'll hand it over to both Ivan and Eddie.
Thank you, Efe. So yeah, I am Ivan Moen. I'm co-founder and product line director at Commit. And with me, I have
Eddie Valverde. Thank you for having me, Ivan. I'm the Vice President of Business Development for Emerald Search Sciences. Thank you for hosting this wonderful event here at your Houston Technology Center. This is a great place to be. Lots of really cool things to see. As mentioned, we're talking about sustainable production recovery. And I think as we go through this presentation, it'll be very clear that that requires an engineered approach. It requires a program of wells and good decision making. There's a lot of evolving technology around this space. And I think we know that getting more out of existing assets is very, very important. I do want to remind the audience that we want your questions and comments. So throughout the webinar, keep those coming and we will address them after we finish with the technical piece of this presentation.
Yeah, so I think to kick it off, let me kind of set the stage a little bit here. I think what we've seen over the last several years now has been a bit of a maturing of the shale business. And here's some data on the left side that was published earlier this year by Enverus. And we're seeing definitely a peaking in individual well performance on new drills. And we're also seeing an increase in fracture-driven interference since we're putting also ultimately impacting wellbore productivity. And I think maybe for the first time, it seems like, at least in the shale business, we're seeing an increased focus on capital discipline as well. So I think, Eddie, the backdrop right now is great to look at existing wells and get more out of those, in addition to also keep drilling new wells.
Really from our experience at Emerald Search Sciences, we've seen a lot of interventions in this space happening with mature wells. So call them in the vintage of 10 to 15 years of age, with some of the really early technology around frac programs. One of the big things that we want to see out of intervention, clean outs, and then restimulations is really gaining efficiency and learning the best practices of all of the work that both of our companies have done. One of the things that we do specifically that I believe help drive efficiency is the use of our hydrolift colloidal gas Afron fluid. It's a variable density fluid. It allows us to circulate a well with no pressure or on vacuum, barrel in, barrel out. And that really comes in a reduction of field water or fresh water that you might want to use for that well during a clean out. And then the other thing that I'll mention, especially since we're talking about increasing carbon footprint, we're talking about allowing our operators to put out better ESG messaging. Our fluid is recyclable, meaning you build the fluid on the first well, and if properly treated and filtered, you can use it on subsequent wells, which means you need way less field water, less trucks coming on location. So both HSE and ESG are covered there. So let's talk a little bit about both sides of the equation here as it pertains to Emerald Search Sciences and Commit Well Solutions. From the wellbore debris side, there's some traditional and some operators even elect to use nitrified fluid to try to decrease the hydrostatic on the wellbore so they can circulate a low bottom pressure well. And all of those systems are to some degree successful, but they rarely ever get past the heel, which means you never really remove the obstruction and the debris from the well. That's really where our specialized fluids and chemical regimes come into play. So being able to modulate the density, being able to generate a fluid that goes all the way down to 4 pounds per gallon, equivalent density, hydrolift, it really allows us to clean the well and then prepare it. So then your excite system can come in and do some restimulation.
Yeah, so as Eddie mentioned, pollution or debris in the wellbore is one main issue for why wells are producing less than what they could be. and another one is formation damage. And I think on the formation damage side, acid stimulation has been historically a very popular way to revive production in the well. And historically, our industry has bullheaded these treatments with somewhat the obvious drawback that we don't have a whole lot of control of where that treatment ultimately ends up in the well. So the approach we have taken instead is what we call a focused restim, where we can divide the wellbore up in many, many zones and then treat one stage at a time with acid. And then with that, ensure that the entire wellbore is indeed treated. And this kind of forms the platform for increasing production from existing wells that we work from. And it's really derived, I think, from many years of experience at our company, and also I think from Emerald Surf, working on older and working on existing wells. And we can probably divide the process into two main categories. The first two steps here kind of become the homework that we do upfront before we actually go out and work on a wellbore. Identify underperforming wells as candidates, identify why they are underperforming, identify if there's anything that can be done to treat these wells and lift production back to where it could be. And then on the operational side, the wellbore cleanout to get debris out of the well, to prep the well for a potential acid treatment on the back end, and then ultimately placing the correct treatment selectively across the lateral. So let's dig in a little bit more into each one of these processes, especially on the cleanout side and then on the selective treatment side as well. So Eddie?
Yeah, thanks for handing that off to me, Ivan. I want to remind everyone as we move from slide to comments, we're both of us are experts in our field, and we can certainly field the questions that you have coming. So really, when you talk about rheological spectrum and the choices that you have around circulating a well and getting the debris out, you go all the way from the right, which is a turbulent flow system, which in our case, we call that fluid rheology control systems. This is a slick water system that potentially you might have to spot some LCM to then get a slick water system to circulate. Some of our newest technologies, our transitional fluid goes from turbulent to laminar. Our turbo lift system is also, you also have the ability there to modulate the density, in some cases down to about 6.5 pounds per fluid. But really, our most successful system is our hydrolift system, which is a laminar flow system. This is a system that has great fluid stability, enormous carrying capacity because of its gel strength, but we can still modulate that density down to 4 pounds per gallon and get that well to circulate barrel in, barrel out. And that's a lot of the successes that we're seeing. And I think some of the case studies that we're going to cover today, Ivan, both from our company and then your company, and then jointly some work that we've done, really identifies the candidates and the ability to circulate those wells with hydrolift.
Yeah, for sure.
So candidate selection, we've talked about that a little bit. I think that is a really, I can't emphasize it enough. Production engineers and production departments really need to do a lot of homework. I know your company can help do a lot of the legwork around that candidate selection. And there's some candidate selection information here on this slide. I'll talk through a couple of them that really stand out to me. Dissolvable plugs. In any well that still has plugs in the well, that could be because the coil unit potentially wasn't able to reach some of those plugs, so they remain in place. The dissolvable plugs, I go back to some comments I made about those vintage wells of 10 to 15 years. Believe it or not, we intervene a lot of wells where those plugs were supposed to be dissolved. They're still there, so that's trapped virgin production. Anything that's frac hit, we hear that a lot today, especially in the Permian Delaware Basin, where you have close spacing and these big frac jobs that are going on. Those wells need to be brought back online. So getting them cleaned out and then re-stimulated is very important. And really, as a production or reservoir engineer, anytime you see a sudden deviation in the type curve, that is a perfect candidate for intervention, clean out, and re-stimulation. And again, make sure that we keep those comments and questions coming. So let's jump in a little bit here in some of the case studies. A lot of information on the slide. I'll be about here is increasing the EUR and decreasing production write-off. So you don't want to write off a well that potentially can be restored or reboosted by an intervention. And what we're seeing in this case study specifically, we're seeing a 46% in MBOE uplift. That's huge, especially from an existing asset that's already tied to a pipeline. You've already got an artificial lift system that you can trip back in the well and get this going well. So really, it's about restoring production and boosting production in some of these existing wells. The backbone of our system is really around live data. So our OpsViewer live data platform is coupled with HydroLift and really any of our fluid systems. Specifically for HydroLift here, our goal is always to break circulation, to get circulation going as early as possible. Sometimes that requires some of our proprietary technology around the LCMs and spotting those before we go chase it down with a 4 or 5 pound per gallon HydroLift. And what you're seeing on these graphs is what our fluid, and that is the increased pressure as we start to spot LCM, as we lighten the fluid barrel out. And that's huge. That's always our goal here. So Ivan, I know that one of the things that shocks some operators the most, especially when they make the trip out to location, is the amount of debris that comes back from some of these wells.
Yeah.
You know, and many times it exceeds the volume of the wellbore in terms of how much sand it could hold. In this same case study, we're talking about 2 roll-off boxes. And any of us that spend time in the field, 2 roll-off boxes is the equivalent of 70,000 pounds of sand. And 70,000 pounds of sand that comes out of a wellbore is significant. So think about how much obstruction that causes when that well is trying to breathe and produce, and that artificial lift system is trying to work overtime to pull product from it. So removing bridges, removing debris is always the goal, and doing that with a colloidal gas Afron fluid like HydroLift with high stability and high carrying capacity is really the key. And in this case study, this is a definition of an intervention and then a restimulation. We're talking about a well that was doing 40 barrels per day, and that well came back online after flow back to 400 barrels per day. So significant increase from an existing asset that was potentially going to be written off.
Yeah, so kind of following the cleanouts and assuming the wellbore also needs some additional treatment. That's when the selective treatment part of this comes in, and this really is, formation damage is a wide topic, but basically we can define it as anything that's blocking or limiting flow of hydrocarbon to keep the well from producing to its full potential. And I'm not going to go into all the details about the sources of this, and I think operators tend to know their field better than we do. But it can be various kinds of scaling, and also a lot of the projects we have worked on has been when we've had to use diverter in the wellbore, and there may be some residual diverter from the cleanout that we need to break down with acid following the cleanout of it. So doing this, we use the isolation system, the Excite system here, where we can space packers out to basically accommodate for pretty much any stage spacing we need downhole, and where we can target each stage individually. So the process is basically to run into the bottom of the wellbore, activate the system, place your acid, unset the system, move up to the next stage, and then keep treating one stage at a time until the entire lateral is treated. And then during the job, we'll also collect downhole data, and also which is going to be on temperature and on pressure. So we basically get a full overview of how effective the treatment was, at least the efficiency of the treatment. I think this is really key, because if we're going to remove all formation damage, we have to make sure we're also treating every stage downhole. And then so some sort of focus restim basically becomes the only way to do that. And then we can verify the efficiency of the treatment on the back end using the downhole data. So maybe we'll dig into a case study on this one too, where this is a case where both a cleanout and a treatment of the formation was needed. This is a frac hit wellbore that basically lost all of its production following a frac hit, we went in, and this is before Emerald Surf and Commit started working together. So this was Cleanout with a Venturi style system. Basically got a lot of sand out of it, got production return, but operator here estimated a 30 to 40% reduction in EUR. So with the well produced for a while. Following that, we came in and did a focus restim. This is a mile-long lateral, 30 stages. We did 30 treatments here with acid. Lifted production basically back to what it was pre-frac hit, maybe a little bit higher, probably due to some flush production. But then looking at the decline, we're basically back to the natural decline of the well. And this is something we see quite a bit. And it makes sense, assuming we can treat the entire well. The Wellbore should basically also be producing according to its curve. So, yes. And I think we'll do one more case study here.
This is the one where we work together, wasn't it?
Yes. So this is in the Midland Basin. It's a 2-mile lateral in this case, 56 stages. So it's a case where we did a clean out and an acid treatment. And maybe, Eddie, if you want to speak a little bit to the clean out to begin with.
Yeah, actually, you know what? I was lucky enough to be out in the field for this job. So the Wolf Camp is historically a nasty field to try to intervene and circulate a well, especially when they're on vacuum. Very difficult operation. This specific operator had tried to intervene it at least 2 times prior using just field water, but the well just kept drinking it. They never could get past the heel. So after doing some engineering work and understanding their system to location on this 2-mile lateral, we averaged 4.3 pounds per gallon. And we did pump some diverter to get the well to seal up and to start to circulate. And then again, we had a tremendous amount of sand that was removed from this well. And once your representative on location looked at the debris that came out, we displaced all the fluid. And my understanding was then they deployed the Excite system afterwards and started doing the treatment.
Yeah, so I think on this one in specific, I was very amazed by the amount of sand we could get out of it. Surprised I could actually fit into a wellbore like that. But yeah, so following that clean out, we came in, we treated all the 56 stages here with acid. Also looking at the downhole data, it was verified that it was placed where it should. I think we pumped a lot of diverter on this one, so we treated the formation some, broke down any kind of residual diverter on it as well. So we have basically a year or so production now. This is using public data here. So, and also talking to our client, it's quite accurate in this case. We pumped a fair amount of water on the entire job. Took a little bit for the wellbore to unload some of that, but eventually production is now established nicely at a sustained higher level. And again, this is kind of what we tend to see in this process. We clean them out, we get the whole well treated. The wellbore production we get out of it is a very sustained uplift.
Yeah, so great success on this well on both parts, and I think the operator came back with it as very satisfied.
Yeah.
So Ivan, let's close this out and then go to our questions and answers. So what the point here is that our hydrolift system is really a consistent and a reliable way to circulate a well clean, to remove debris. In some cases, we will have to treat the well prior with our Part C diverter. We do have a new technology out now called Part C Max, which is a slightly different diverter than Part C. It's got more oomph and it seals quicker, and it's really for those wells, especially something like the Wolf Camp that we just talked about, where you really need to get those fractures sealed off so that you can circulate the well clean. So again, thank you for having me and having this conversation. And anybody that ever wants to come see this facility would be amazed at what you have here.
Well, thank you for that, Eddie. Thank you all for hosting the webinar with us. We're working on numerous projects by now, so I think this was a great opportunity to showcase the technologies for both of our companies and also kind of how we tend to fit together when we do projects together. I think as we discussed, there's a lot of steps in reviving wellbore production that has to go right. And for us to commit working with Emerald Surf was little bit of a missing piece in our process in terms of prepping a well and cleaning it out, especially the really depleted ones, before we go in and do a selective acid treatment. So yeah, I think this is a good kind of high-level overview of applying cleanouts, applying selective treatments to do sustained production uplifts on existing wells. With that, I guess we'll open up for questions.
Yeah, let's do it.
Yeah. Do you want to start out?
Sure. So let's see here. In terms of what type of Afron systems are on the market and what the customer can expect, from our side, these are very similar to chemical add plants, so not much bigger than a standard skid or trailer that shows up on location. I would say that from the standpoint of footprint, it's easily fits on any well site. Our system is not batch mixed, meaning we come out to location, we plug and play with a coil unit or the workover rig, and then from there we're able to start making the hydrolift fluid fit for purpose to the rheology and to the density that's required. So very easy process. Generally, a intervention cleanout takes 2 to 3 days, 5 days on the long side if it's a very long lateral.
Let's see. Another question: Can proppants be pumped through the Excite system? So yeah, the answer to that is yes, and it's something we've done on a handful of occasions as well. So it is. I think the original design for the Excite system was to be able to be compatible with proppant from day one. So yeah, we've done a handful of those jobs. Operationally, they are quite challenging. There's a fair amount of things we need to consider on them in terms of being able to circulate and these things. So it is it's not something we do all the time, basically, because we're asking a lot from the Wellbore, but it's definitely possible to do, and it's something we can kind of more do on a case-by-case basis.
Excellent. Another one that's just popped up here is a question around the recyclability of the fluid. So it really just depends on the basin because it's very temperature driven, and it depends on the application. If we're getting a lot of hydrocarbons back as the well starts to flow, that tends to degrade a system that is xanthan based. But for the most part, in the Permian Basin, the Delaware Basin, you're talking about 3 to 4 wells that the base fluid can then be recycled to subsequent wells. If your operations are in Wyoming, Colorado, North Dakota, where the temperatures are much cooler, then the ability for recycling is we've had customers that recycle the fluid up to 6 to 7 wells, and then holding the fluid in the cooler climates, you can hold the fluid for 7 to 10 days, as long as you treat it with biocide and you keep rolling it. Warmer climates, you're talking about the window's probably 3 to 5 days, and then it needs to be back pumping and back down the well so that we can treat it as we recirculate it. Yeah.
All right. Another question that came in is, how is the Excite system deployed? So I think operationally, basically, we activate and deactivate it basically by flow. So we'll pump through it to activate it. We stop pumping, it will unset. So with that, we need some sort of tubing. And that can be jointed pipe, it can be drill pipe, or it can be coil tubing, basically anything we can pump through. I think the way it depends, it comes down a little bit to each individual application too, but a lot of our domestic applications in the shales has been through using a workover rig that makes it easier to space out the packers to 200-300 foot to accommodate every stage and stuff downhole. A lot of our international work tends to be maybe a little bit more on the cool tubing side, but at a high level, basically any tubing we can pump through, we can also deploy the system on.
Interesting. Now let me ask you this from my perspective. When it's being deployed, obviously you have a qualified technician or engineer that's on the floor running this. When they're running the tool in the hole, are they going all the way to the toe and then working their way back? How does that work?
Yeah, good question. So I think basically basically, as long as we can get to bottom on the clean out, we can start from stage 1. If we don't get to bottom, obviously we'll start, above, basically above wherever we got to the clean out. But yeah, for the most part, we can make it all the way down. So then we start at stage 1 and we work our way back to one stage at a time.
Gotcha. And that leads us to another question that I think segues into this. It is, how do we know that the Wellbore is clean enough to be able to deploy the Excite system? So from the fluids perspective, what we usually do, and it generally is every hour. Our field engineer is doing a QC QA test, meaning they're looking at fluid stability, fluid density, fluid viscosity, but the important one for understanding is the well clean enough is the sand content test. Now let me back up a little bit and say that with a system like Hydrolift, where we are really modulating the density down to 4 pounds per gallon, sometimes when we run our diverter, our Part C or Part C Max, you're talking about the well requires a 2 or 3 pound per gallon equivalent to keep from taking the fluid into the reservoir. For those systems, you have to have a centrifuge on location as your sand separation system, meaning a conventional Sandex or Sand Command or any sand separation system like that will not separate the sand from Hydrolift because it won't fall out. So the centrifuge, you can visually see the sand that's being removed, but then it goes to a set of filter pots on our end, and then we take a sand content test. So we take one before the centrifuge, after the centrifuge, after the filter pots, and then we're knowing, okay, if we're getting less than 25% sand back, we're starting to understand that, hey, we're kicking down the amount of sand that's in the well. We'll do several bottom observations to confirm the well is being cleaned, and then at that point, that conversation is had with the company man, the engineer, and they're satisfied that, hey, this is as clean as this well is going to get. We're satisfied with what we're getting back from flowback, and this well is ready for the Excite system.
Yeah, I think kind of maybe a follow-up question on that. I mean, is there, from your perspective, a preference in terms of doing a clean out on a workover rig or using a cold tubing unit? Doesn't matter.
It doesn't matter. From the standpoint of what we usually see, so we've done over 1,500 jobs that are in our database. I would say overwhelmingly, call it 70% of those have been on workover rig, because in U.S. land, that is the most widely used method of deploying tubing down hole. Whereas cold tubing units are generally dedicated for frac plug drill out operations. But we have done and are currently doing multiple. We have in the Eagleford, up in the Marcellus, we're doing through tubing interventions with small diameter coil, where the coil is deployed through the tubing. You get outside of the tubing, you circulate that well clean. So we can work with either. I would say just the data shows that workover rigs tend to be the most preferred method, because you can reverse circulate with them. You can rotate and agitate the debris as you get it out. And then, as you say, you can run the Excite system on that same tubing.
Yeah, I think that's kind of what we've seen a lot too, is that the rig is out there, you guys are doing the clean out. So doing our treatment on the back end of it, it basically just adds like a day to the whole thing. So it's becomes a very smooth operation at that point.
Excellent. A couple more questions. Do we have time for that?
Sure. Excellent.
Okay, so there's another one that I see here around BHA tools, and how does our Hydrolift fluid work with conventional? We'll start with coil tools. So on a coil tubing string, you're going to have generally below your connector, you're going to have potentially an agitator, sometimes a bypass sub, and then a motor. Because we are doing these QA/QC tests at surface, we know that we are not recirculating sand, which would be very abrasive to a downhole motor, and especially to an agitator. So downhole tools, no issues there. Remember that the colloidal gas after-on fluid is not what you would think of as a nitrified fluid, meaning there are no big air bubbles. So downhole motors work just like you would with traditional mud or traditional slick water. The fluid is compressible, so there's no issues with pump cavitation at surface, meaning we're not going to stall motors because we're having, large air gaps being pumped through the tubing or through the cold tubing string. So from a BHA perspective, independently, multiple tool companies out on the market, TTS, NOV, Baker Hughes have all tested our fluid on their elastomers, on flow loops, and have verified that there are no performance issues with pumping very low density high lift through them.
See, one more question came in. Have you run chemicals on wells or only acid? So yeah, we definitely run chemicals. I think acid has been the most prevalent one. We're quite agnostic ultimately what we pump beyond. And what's important for us is that what we pump is the correct treatment for a well. So I think sometimes that is acid and sometimes that is something else. So we've done scale squeezes, we've done surfactants, we've done a lot of things that we pumped through our system. I don't know, from a percentage wise, probably at least 70% or so have been acid treatment. So that's definitely been the more popular method. And that tends to kind of, some of the data we were showing earlier too, and I think the last year there was a webinar by one of the big data firms showing basically that acid tends to be the most popular way to revive well productivity. And I think we can definitely attest to that, look in our track record, but at the same time, it needs to be the correct treatment. So yeah, we can, I think the Excite system becomes very much just like a vehicle to place treatment, and then the treatment needs to be appropriate for the individual well.
Well, while you're on that topic, I thought of a question that I had, and you and I have not been able to have this conversation. So when your customer, the operator, identifies a well that they want to do a treatment on, how involved is commit in terms of choosing the chemical treatment? Is that something that is something that the operator does specifically on their end because they understand the reservoir and the scaling or whatever near wellbore obstruction there might be, or is that something that commit does on their side?
Yeah, that's a really good question. I think we're very concerned with the fact that we find the correct treatment. And I think it depends very much on who we work with. Sometimes we work with some of the bigger operators. They know a lot about have a lot of data, a lot of historical experience and everything on operating their fields. They know exactly what's needed. Other times we work with clients and maybe just purchased a large number of wells, right? So they just bought 200-300 wells. They don't know exactly what they have. At that point, at least, we have the ability to pull in expertise when we need to. We have the ability, we have like a process we follow to at least kind of do some homework to find the right treatment. So I think it doesn't do anybody any good to have an operational success, if you will, on the wellbore, but where the treatment ultimately didn't really do anything on the production side. So it is it's one of those. I think it's in our interest, but in our client's interest, but certainly in our interest too, that what we're pumping is actually going to have a meaningful effect on the well.
Excellent. So it looks like we've had another question here. How do operators designate candidates wells for CGA applications? So CGA, colloidal gas apron systems. Great question. Actually, anything that's low bottom hole pressure. So if you're dealing with a well that has 2,500 pounds or less of bottom hole pressure, if you do the math on a slick water system, you're going to very quickly overload the hydrostatic burden of that well, and you're going to lose fluid as you're trying to pump it in. Many operators elect to try first to pump field water because that is the less expensive method. If they have field water access on location, they can just start pumping it. But what they'll find is they'll lose barrels. And remember, when you flow that well back, that water has to come back before product comes back, right? So before you start getting your oil back that you're going to put in the pipeline, you have to get all that water back. So really looking at wells with low bottom hole pressure is a must. We will help you from the engineering side come up with a procedure that says, when we start this well, we're looking at 6.5 pound per gallon fluid. But we see that the lower part of that well, as we poke through obstructions, the bottom could fall out of that well, and we'll have to modulate that density back. So again, one of the reasons that we've had so much success is that we have the only system on the market that where the density can be modulated on the fly. So because it's a recirc fluid, we can always change the fluid from 8 pounds per gallon to 6 pounds per gallon to 5.3 pounds per gallon, back to 7 if needed. So again, our goal is to circulate the well at balance so that we put very little fluid on the formation, and then that reservoir engineer doesn't have to worry about all the flow back that they have to deal with after the cleanout.
I guess maybe a good follow-up question on that. This sometimes we use diverter in these wells to be able to establish the circulation to get them cleaned out. I mentioned a little bit on during the main presentation here as well, but could you speak a little bit in terms of the the diverter? Does it break down over time? Does it break down with acid? Like how do we ultimately make sure that the diverter is not becoming also a block to any kind of production?
Yeah, well, good question, right? Because the diverter is there to seal the wellbore so that we can circulate, but then at some point you want to remove that.
Yeah.
So our Part C diverter is a cross-linked polymer, and we blend it with a proprietary osmotic barrier, meaning that produced salt water, produced brine will not affect it in the short time, right? In the near time, it won't affect it because a cross-linked polymer, by definition, is going to be very sensitive to salt. It will shrink it, which means your ability to seal off that wellbore is decreased. So our osmotic barrier is temperature and time driven. Over time, it will break down, and then once the produced water, the brine, comes in contact with it, it will start to dilute it, and then it'll just come in as flowback. But our general our recommendation is as you touch the toe and displace hydrolift, we start to spot acid. How do we do that? Through our lab data system, OpSphere, we know exactly where we spotted that diverter, and so we pump acid on the way out. Generally speaking, that decision is made between Emerald Surf and that production engineer. We decide how much we're going to pump, when we're going to pump it, so that we can break down that Part C diverter, and then it's out of the way, and well can either be rated for flowback, or the excite system can be tripped in for stimulation.
Yeah. See, are there any more good questions here? Yes, that was a good one. I guess we have time for at least one or two more. I think this probably goes for both of us, but how do you identify a good restim candidate well? I can maybe start out on my end. I think what we're talking about here, especially as long as if we're not pumping any kind of proppant, my feel on it is that we're very much in the production adding back business. And so it's a wellbore that it can grab a lot of numbers, but it's producing currently 50 barrels a day, and it really could be doing a lot more. And that's the opportunity to go in and, if we can find out why it's producing less than what it's doing. Is the debris in the wellbore? Is it formation damage? Is it both? That's where we can ultimately go in and add that production back to the well. And I think, formation damage, if that is the issue, and it's probably never going to be distributed evenly across the lateral. But I think what we have seen anyway, the times when we can, if we do our upfront analysis, we basically identify this is a wellbore with a significant uplift potential. That's really when going in, making sure we treat the entire lateral becomes important, because otherwise we also potentially leave a lot of production on the table if we don't get everything treated. So.
Well, and let me make a comment about that, because we routinely get this question from engineers about restimulation. And generally speaking, if you think through it as a return on investment, if you're already making the investment to pull tubing, to intervene the well, to have a 24-hour rig on location, if you're going to remove all that debris, you should take the next step to restimulate, because you're 75% there in terms of the operation. And one thing is removing the debris and getting the well to flow back with product, but what's behind that pipe? And generally speaking, that is where your system comes into play, right? You're able to get behind that into the fracture zones and then be able to treat whatever's impeding that production. So I would say best practice is, if you're going to intervene a well, you're going to go through the whole process of performing a clean out in that investment. It doesn't take much more to do a restimulation.
Yeah, that's correct. I'll start with this one too. That's really good. Are all good cleanout wells, good restim wells too? And you kind of alluded to it here a little bit. So I think it was a good.
Well, Nostradamus, right? I can tell what's coming.
So I think, I mean, my opinion on it, I think it is, if we're treating a well, we should be treating for something. And so, ultimately we need to kind of identify a little bit, what are we treating for? But, at the same time, if we're, going into these wells, if we've pumped diverter, if we've done these things, also, not just spotting acid, also pumping acid into the formation helps to ultimately make sure we've dissolved everything. I think at an academic level, the answer is probably that some wells are candidates for a Cleanout, some are for Restim, and by the time it's going to be a Restim candidate, you also need to prep and clean out the well. But in reality, it ends up being a lot of the wells that we can clean out. They're also really good candidates to do some sort of treatment on.
Yeah, let's take that a step further, because one of the things that the industry is seeing is, I think the clean out, the restimulation, we're going to be seeing more of that, because one of the things we've learned is that now with the advent of colloidal gas saffron fluids like hydrolift, with selective isolation tools like the Excite system, you can do some things that you couldn't do just 5 years ago. But I also believe that if you look at the rhythm of the industry and the push towards refrac, there's a lot to be gained on a refrac, much more complicated operation, because you have to remove and drill out any frac sleeves that are left in the well. You have to install a refrac liner, and then you're going to have to get a frac fleet out to refrac. So I think the happy medium is wells. Any well that you're going to clean out is a candidate for restim. Because again, I go back to, you've done 75% of the investment is there. And before you move that rig off location to the next well, I think that next step, the natural next step is to go in and do a restimulation. Better odds for better production. And at the end of the day, that's the gain that you're trying to get, right? More barrels out of that well.
For sure. So I think we're coming up on about 45 minutes here. I think we're running out of questions. So I guess we can maybe wrap up the webinar. Thank you again for one, hosting, and being a good sport.
No, this was fun. We should do more of it. I do want to remind people that our contact information are on the slides. You can always reach out to us with any questions that you might have that maybe we didn't get to. And then, of course, I know, at least from my end, and I know from your end, there's a group of very technical engineers and departments that support us and can run a lot of procedures, that can run a lot of KPIs, that can provide data around making better choices on intervention, cleanouts, and restimulation.
Sounds good. All right, we'll wrap it up with that. So thank you for everyone who joined us.
Have
a good day.
Thanks, everybody. The recording will be sent to all of you that registered and attended. And as Eddie and Ivan mentioned, feel free, if they couldn't get to your questions, feel free to reach out directly to them. All right. Before I wrap up, I would like to just extend sincere gratitude to both commits and MLSurf services for making both of them available for this webinar today. All right. Bye, everybody.